Hello. Yeah, I will actually do one more thing while you're thinking about it. I will get more paper. Hey, at least it's working. Okay. Did you all manage to take a look at that exercise? It looks quite, does it look quite clear? There's even something here. And why would we ever want to convert to Fahrenheit anyway? Yeah. Who wants to convert the temperature to Fahrenheit? Nobody? Who uses Fahrenheit? Look, temperature scales here and there is the conversion. This is that you will use the Celsius to Kelvin. This makes actually sense, yeah? Because the Celsius and Kelvin degrees are the same size, basically. If you have temperature changes, it's always the same in Kelvins and Celsius. But then when you come here to Fahrenheit, it's like, is this like very clear or what? Who uses Fahrenheit? Americans, yes. Who is American here? We can't blame anybody who is here, yeah? Of this exercise. Okay, so what it was done here is that we know that 100 Celsius is 212. This is just an example, you know, of something. So maybe we still don't have to like do this kind of converting to Fahrenheit. It's not for the sake of converting to Fahrenheit. This is just an example. Okay, and then there was this, somebody nicely has drawn here a picture, yeah, like we did the last time. So I know something now if I put there, for example, the Fahrenheits there. Here, and then I put the Celsius here, like on that picture there. So Fahrenheit and Celsius, and then I start marking these things. So if I have 0 Celsius, so I'm here, I put 32 Fahrenheit, so I have to do some kind of division that makes sense. And I have to go to 212, so maybe I would do here 100 and here 200, for example. If I would have here 100 and here 200. Oh, but well, okay, it sort of fits, almost. Not well drawn, yeah? And then with cells, so I start with 32. So here I would have 50. And then 25. So 32 would be somewhere here, maybe. There's my 32. Did you do this also? You tried to do the equation, did you? Okay. Yes, cool. That's really good. Okay, so I start with 32 and then I go to 100. Yes. So where is my 100? For example, this would be maybe I have here 20, 40, 60. 20, 40, 60, 80, 100 here. And then I just like 212. So then that was 25 the next. So then I go to somewhere here and then I draw and then I think about This is a like not the best solution, yeah. So then I have to think if I have 100 Fahrenheit, wasn't it? If the person has temperature, then I go from 100 here. And then I go to the Fahrenheit. There Celsius from Fahrenheit to Celsius. How much is that? So here would be 40. This was 40. Difficult to know. Okay. So this is not the greatest solution. I could have maybe done a bit better division then. So somebody tried to make an equation about this. Yes. Yes.
So the
Yes. You knew the equation. Okay, cool. I didn't, because in Finland we really don't use Fahrenheit. So why would you use anything else? But it feels really silly, with this. You also have on your islands, you have weird units for something. I know. So then we would put here the points, for example. So we had the points like here would be our first one, yeah. So we would put, for example, like this, x1, y1. So there was the point, x1 would be the 0, and y1 would be the 32. Yes? So then we would have the x2, y2, and these would be the 100 and 212. And then we had the equation from the technical formulas that we looked the last time. Give us this one here. So now we can make an equation here. Yes, this is most probably what you already remembered, and then you. So I go to the technical formulas and I find this is the page 28. I find this y minus y1 is y2 minus y1 divided by x1, like this. And this was something that in Finland we called the K. So this is like like what we did the last time. So I'll first, for example, calculate the K here. So I put there the y2 was 212, and the y1 was 32. And here 100 and 0, yeah? So then we get this one from here. Maybe somebody of you didn't draw, but it's something like this, yeah? No. But does this look like reasonable to you now after the last lesson? Yes. So this already sort of quite well, what I'm doing. Yeah. And divided by 100, and then we get something. So we get 9 divided by 5, and I think we actually get, which is in decimal number, 1.8. Okay, so we got the K, and we continue with this equation now. So we put there the y1, 32. There the K, you can put it in either form you want. For example, like this, because both of these are accurate. In this also, there were nothing after, so you know that it's accurate. Yes? There I will put then the x. And what is the x1? Well, it was 0. Pretty simple, yeah? And I get the equation for this line that I draw. Just like we did last time, but this was a bit more practical example. So there's y minus 32 is 9/5 times x, and then I want it with the y, or I wanted it in the function form. You know, the solved form for the line. So I add 32 there. I get the x plus 32, or maybe the equation that you actually remembered. Was it 1.8 x plus 32? Okay, but now I don't actually get the I can't solve my problem, can I? Because I wanted to know, like, now I have the Celsius here. So I did it in this, it is a bit silly, why didn't I? Because I wanted to know, let's take another number. I wanted to know, like, 100 if I want to convert it to Celsius. But with this equation, I actually convert the Celsius into Fahrenheit, don't I? So the Celsius is on this line. So it's the one that I can with this equation, I can put any value and I get the value in Fahrenheit. But how about this? I didn't really get anywhere, did I? So maybe you did it the other way. Let's do it the other way. Huh? Now we are getting into what we are supposed to, sort of. This is just an example again. Let's put it the other way, yes. So we put the Celsius now here. Here is the Celsius. I hope that my axis is okay. And here is the Fahrenheit. Oof. And now I have again the same points, but they are the other way around, yeah. So of course I have 100 Celsius is 212 Fahrenheit, but if I put them as these points here, I have to put them the other way around. So maybe I use another color. X1, Y1, the points for this line that I can form the equation. I can also draw it if I want to. I can do many things. So if I want to have the Fahrenheit on as an X, I have to put it here, yeah? This would be 1 point. Yeah, and this is actually let's not put that point there, of course, it's the other point. So the first point here, this would be 32, and this would be 0. 32 and 0, and the other one 212 and 100. Okay, and now I could draw it, or then I can just start calculating the equation from there, just like I did before. So with this, I calculate first, for example, the K. The K. And why the K? Because it says K here on your equation book, you know. This is the solved form. This is the form where you solve it from. And this is the K here. Yeah? You remember this from the last time. Yes. So my K here, And this was again the y2 minus y1 divided by x2, x1. But now it's the other way around. So my y1 was y2 was 100 and y1 was 0, exactly the other way around as we did the last time. And of course we also get the reciprocal of the previous here, yes. So it's 5 divided by 9, yes. And then we can make the equation for the whole equation with this. So y minus 0 is 5/9 times x minus 32. This was my first point, and I put it into this equation here. Now it's here, and now I get something different, of course, here. So 5/9, and then I still have to remember to multiply with this. So when you have something multiplier here in front of the brackets, you of course multiply both of the terms in the brackets, yes. So it's not only this and then minus 32, but I have to multiply it with this. And I actually get 5/9 times 32. I get something like this. It can't be, what was the correct word? Reduced any further, or then if I take I lose some information. So I'll put it like this. Minus 160. Like this. Now I have the equation for the line that I didn't actually draw. Yeah, and then this is actually the fx. But now I have it the correct way round, yeah, so that I can actually solve the problem that I had. So now I can adjust there the 100. Are you still following what I'm doing? Yeah, I'm doing. Isn't this going quite slowly? Even frustrating. Is it frustratingly slowly? No, it's okay pace. Yes. So I adjust this there, the 100 on the place of x, just like I did the last time, because I wanted to know, so I can put here, my Fahrenheits are here on this axis. They are the on the x value, and then my Celsius depends on them. So this is the correct conversion formula now. And then I get something, and I'll just calculate it with a calculator. So I have 5/9 times 100. Oops. No, times 100 minus 160 divided by 9, which is something like this. So now I actually get the correct answer here after all this hassle. 7, 8, maybe. Is this now fever? I think so, yes. Yeah, what do you say? Okay, yes. Let's look at that as well. Okay, this is interesting. Can you show it here? Okay, cool.
So it's like having to do this equation. So but the same as 1.8.
1.8, yes.
Then like do this to this equation.
Yes, yes. This is something you can do as well. Yes, yes.
Then
So that's true. So you insert it there. This is, yes, thank you. Really good. So the way you can do this as well now, how you can use these equations. So we have these equations here. This is good. We are getting somewhere. So we had the two equations. I was using the first here. And you can do it more simple way as well. Maybe there is also in the solutions, it's this. So these two equations here you can use. So I'll write the equations here still, and maybe I'll use another color again. So this is from the technical formulas. And we have y minus. We are now very familiar with this, aren't we? X2 means x1 and there the x minus. The other equation is this. Y is kx plus b. So you could have done it straight with this equation as well. Like this. So here is the way to do it. Do it simple way. So you solve the k, just like we did from this equation. Yes. So this is always for the k. Let's call it the k, because it's the k there. And then you can adjust to this equation 1 point. So you have solved the k, and the k was, I know that the k is 1.8. So here then you put 1.1 y value, which was here done 212, and then 1.8 times, and then you put there the x value, the how do you say, the x value of the same point. So there's this point being used, and now there's still the b. Now you can solve the b from this equation, just like was done here. So I calculate the b now. And this is, of course, I multiplied that with 100, that's 180 plus b. And then I just solve the b. So the b is obviously this 212 minus 180. And I get the 32. Yes, thank you. Very well done. Did many of you do it like this? Maybe you already learned it in school to do this way as well. Yes. So these both equations work, and this might be even more simple. Well, okay, and now we are still lacking this, the line. So what did we do then here? Because we got two different kinds of formulas, and we did many things. So I will quickly show you some theory of this, as long as I get it. Let's put this, for example, there. No, it's here. this. Whoa. Not that. No, I have to put it like this. Let's go to the beginning. Okay, so we did this kind of inverse function. Just like that. So has somebody of you heard about inverse function before? Maybe the ones of you who did some more advanced maths. Inverse function reverses the effect of the original function. So if f(x) is y, then the inverse function that is marked like this, like the reciprocal, but it's the reciprocal of sort of the function. Yes? With y, you get the x. And then there is even more if you like inverse this. Take an inverse of this, you get the x. And also the other way around. But this is like mathematical writing. You don't really have to know more about this. This function that you want to make the inverse function of must be one-to-one. That's called bijective. Have you ever heard this kind of a word before? Yeah, so each x maps to unique y. So there's only one value of y to each x. Horizontal line test, okay, we're not gonna do anything like that, but there's some kind of there's this kind of a test that you can test if it's an bijective. But for example, this kind of a curve x on the power of 2 is not bijective. How do you say? Unless it's restricted to the values x is greater than 0. We can then think about this maybe later, because soon we maybe come to that kind of function as well. So how do you want to get an inverse function? You start with y is fx. So you swap x and y and solve for y and rename y as. Okay, so there are steps, for example, for this kind of a function. So step 1 is that you have the function there. Then you swap the x and y terms and solve for y. And then you get the inverse function. And then, so we could have done that as well here. The graph is reflection of fx across the line. Y is x. So it's across this x-axis. We can even try that. And here is the temperature conversion, Celsius to Fahrenheit. And the inverse is also Fahrenheit to Celsius. Yes. Maybe I'll draw these two ones with the GeoGebra, for example. So what if I put this here, and then I put here some of these, this, for example, and I put the GeoGebra there. You can also do it if you want. Yes, but I don't know if it's, this is a bit, I have to go do it this way. Like that. Okay, so I had y is to x plus 3. And then the next y is here. So y is x minus 3 divided by 2. So this would be like 0.5x minus 1.5. Yeah. So this is how it looks, the inverse function. What did it say still here? So, yes. There, graph of the inverse function is reflection of the function across the line. Y is x. This is the line, y is x. So this is what it means. We could also draw these Celsius and Fahrenheit height functions there if you want. We want to. Let's put that still. So we got first Celsius. We got the 1.8 x plus 32. And then the other one was does this go now the correct way? Well, let's see what happens. We got 5. Now that. Oops. 9 x. It doesn't show that. We're doing something weird here. Minus 160 divided by 9. I don't know why it doesn't draw it, but it should. Okay. It doesn't want to draw it. Nothing, no. But for sure they will look nice when it works. So that was the inverse function concept. That's just one mathematical concept. Yes, this is like then this is connected. This concept is connected to many things that when you sort of prove something. So you prove that something has something. So it has to be many times this kind of bijective. So it has to have an inverse function. So then you can have certain other things to it that will then come later on the maybe the engineering mathematics too.
Yeah.
But now you know what's the interesting. Okay. I thought that it's just here when we got this kind of a calculation, it's sort of why not to do this? Yes. Okay. I think I have, okay, this works. I don't know why this doesn't work. Because I actually here, I have too many pages open. Okay, I can still try to do it again. And this is not supposed to be here. oops. So we did an inverse, this function and then an inverse function. Should I try to draw it here? So then, but then if the scale is different, does it look? Okay, I will maybe still do it, but maybe we can progress. Let's put this away, and then we need the other course here. Maybe this. Yes. So how about the rest of the exercises? Have you already done them, or should we just maybe stay on this topic still this lesson? Or do you find them really simple?
From the for now.
Did you already do these exercises here? I don't know what is. Not all. Yeah, maybe it's good practice to think a bit how to form an equation. So we could continue with that still this lesson. Yes? And there's also some kind of solutions. This is also like I thought that there's some kind of solution here as well done with the AI. Here's actually the similar way of solving this. So there's so many ways of using the equations. For example, everybody does it a different way, even with a simple equation. We already went through this. We even draw then these are not word exercises. This is just how to solve just this, just solving something from something that looks like this. But then there's still a couple of more. The soda can, then these ones were as the examples in the GeoGebra book. So maybe you can think those through as well still. Yes. Oops. here, if you draw this picture, it actually looks figured the same, but it's just the division on the axis is not the same. So, but you know, the function and the inverse function, the way they look like. So now if I would ask in the exam for you to make an inverse function of some really simple function, would you be able to do that? Yeah, maybe I can do a couple of the kind of exercises for the rehearsal before the exam as well. Yes. By the way, if the solutions are like this, there, are you able to follow it if there's some Finnish text? It doesn't matter. Yeah, it's fine. Is this easy, this can and soda, for example? Because in Finland is also that when you buy the soda, the can costs something, because then when you return it, you get that back. Yes. So you collect all the cans and then you get money. Mhm. Yeah. Yes. Yeah. You can even get quite a lot of money if you have a big party. Or if you go to the festivals, for example, and people are drinking and you collect the cans, you get a lot of money. That will actually like makes a lot of sense. Yes. Yes. And even when you are at the festival, then you also, there's even a bigger, how do you call it in English? Because in Finland we call it pantti. That you get when you return the can, or you buy the can. You know, what is the thing called? I don't know that in English either. Yeah. Okay.
I don't know when cards. No, when it's on cards without that. It's it,
Okay.
That again, the fun.
Yeah, I think so. I don't remember that, but I think I've been playing that, yeah, when I was young as well. But that's a long time ago.
I still look that word from there.
Okay.
Yeah.
Yes. So if you go to festivals, you get really big pantti, and then some people even get the tickets to make money. So they go there, and then people, they throw things around, and it's just you might actually get quite a lot, even if the ticket is expensive.
Yeah.
Okay, whatever. That was completely beside the point. Well, this is exactly how it was done there, but like just to form an equation to this kind of, and then just solve it. And there doesn't have to be this, it's just the euro, but okay, whatever. You can also mark it just with the numbers. 1 minus 0.32. So that was this was here, you would get 34 cents of a can. This is quite a lot. How much do you usually get of a can? 20, yeah, or I don't know. I don't remember how much you get, but like, of course, usually my kids do it. Yes, they want to get money. So then obviously the soda would be then 0.64 or 66 cents. This was the can. This. How about this exercise? Is it easy to form the equations, basically? Makes sense. So you can also like draw it if it helps beside the dog. So you put some pole. Well, this can be a pole. Just drawing something. So some of it was in the mud. 1/3. Okay. 1/3. So here's the level of the ground. Then 2/5. How much is 2/5? 2/5 of the water level. And this was 80 centimeters. The water level. And then the whole length, of course, can be marked with L. The whole thing would be L. So then you just have to realize that this is 2/5 of the L, and this is 1/3 of the whole L, and it's totally the L, yeah? Or any other letter that you want to use. Do you like this kind of exercises? So, or is it like easy to think something like this? I think this is very like engineering type of an exercise. Very practical. So everything was L, and it was done with 80 centimeters and plus the 1/3 L. And then you just solve how many centimeters is the L. Is it solving the L from something like this easy?
You want to get L on its own.
Yes,
Yeah.
exactly. Yes. So what do you need to do? You have to have all the terms with the L on the left side again, and everything with something else on the right side. So you seem to have quite many terms with the L already here. Yes, there was this, then there was this, and then you have to also throw that there. So you just take it out, yes. And now you can also take out the same time the -80, or you can do it with a different step. So then the L went here. Is this maybe the other way? I don't know. It doesn't matter which way around you do it. So the L you remove from that side, and then here you got -80. Yes, that makes sense. And now it looks better, and then you just have to like calculate these together. For example, with the like, yes, like it was done there. So you have to put this, what is the denominator, the smallest common denominator for these. So you would most probably like this, it would go, yeah? And then you'd have 6 of the 15th L, then you have 5. And then there's still the minus L, which is, of course, the minus L in total is 15, if you are in 15s, if you want to think it like this, that way. So that's the complete L. And here you still have the minus 80. That didn't change at all. And here then in total you have plus 11, yeah, and minus 15, so you get minus 4. Yeah, minus 4 over 15 of the L. And then here you have minus 80. If at some calculation like this, you would manage to get something with the minus sign of length, then you know that at least it wasn't correct. But now it looks good because the minus is on both sides, yes. Have you ever done anything, a calculation like that, and that happened? I for sure have. It's like, this can't be correct.
Well, you can just take away the 90.
Yeah, you can. And this would be actually the same thing as if you would multiply it with minus 1. This is just showing the mathematical tricks. Well, okay. You multiplied it with minus 1. So it all looks better now. And then for example, now I say I multiply it with the reciprocal. But you don't have to think it that complicated way at all, do you? But you can if you want. You can if you want to. Of course, I'm multiplying with the reciprocal. If you multiply the reciprocals together, they make 1. Yes. So of course you want to have 1 as a multiplier of this because then it's there alone. And on the other side, you get this 80 centimeters, and you can even calculate this in your head because you can take that. Okay, let's not do this yet. This means you have something under, if you want to do it, this way, and then when you are an engineer, you just use the calculator. It means that this is here, and then you can just do like this. So then you get 20 here. 20 here. So 15 times 20. You get the 300. If you want to. This is pretty easy when you were building something and you needed to do it quickly and you didn't even have your calculator or something like this. Why not? Some people who do this kind of practical work, they're actually pretty good in this kind of thinking. Like, for example, if you build something from the wood, you would be a carpenter.
Yeah.
Yes. Yeah. So you'd okay. Yes. There's still 1 to go. This is also pretty simple. But something like this, of course, you will then have in the exam, yeah? To form some kind of a sort of simple equation and solve it for some kind of written exercise. But something like really simple, you don't have to be scared about that, yeah? Yeah, so this is what I got from the AI. You get these solutions quite quickly there from there. How many seconds does it take? 2 maybe, and that's done. So then for this sort of new exercises, I just put them there because then it's just there, as a solution, and it's not like handwritten. I don't have a handwritten for that, so it's of course a lot easier, a lot faster. What is this now? What you get from this kind of calculation? So you get this is something that where we didn't go yet. How to solve it. But we will go there soon before the first exam. So I was forming those, and I knew that I have certain number of the guests, and I didn't actually know how many. And like there, the ChatGPT marked it with the big G. That makes sense. Then I didn't know how many rows I also had. That was the quests. Then they had the rows. Of course, you can mark with R. And then, so you always have, of course, the same number of quests, but then you don't know in how many rows you want to put them. Of course, maybe you want to have a seat for as many as possible. Yeah, maybe you need to fit them all, then maybe you need one more row, yeah. Maybe you don't want to leave anybody without a seat. But you had some information there. If 12, then it was 32 without 13, and now it's 9 without. This is actually this what is it called? System of equations. In Finnish, it would be yhtälöpari. So it would be called like a pair of equations.
Yeah.
So you get actually, okay, I'll show this quickly in GeoGebra. I hope it works. No, I'm in the wrong place again. First there, because I can't Google anything without putting it to Google. There. And then I write, no, I don't want this. And then just quickly those y is 12 times x. No, 12x. It takes it like this, plus 32. And then next, y is 13 times x plus 9. Just like that. And now oh, this doesn't look really good. Let's put it bigger. Once. Ooh. We can get the crossing point of the line. For sure this also calculates it to me. This is not now very informative, because the crossing point of the lines is obviously there in the what was the number of the guests? Yeah, 300 and something. So this is Yeah, so they are like lines with really similar slope. Yeah. And now then they cross somewhere, and the crossing point is the solution, but you can't really see it from here, can you? No. You just have to calculate it, yeah. Doesn't look great, but that was what I was aiming for. Not great. 308 would be the crossing point, yeah. So that was the system of equations, and now you can just mark, because of course they cross each other in the same y value. Yes. So I had the lines fx, this, because I now use x. You can use whatever you want. This is what you do with Jaakko as well, don't you? You just make some kind of, you have an equation and you put it into the some kind of figure, and then you get some. Okay, so this, of course, when these lines go, whatever lines they would be, and they go something like this, and here is the y value, y, which is fx, and here were the whatever x values. But this is what you want. It's the same y value for both, yes? So this is what you're aiming for. Now I already taught, now you already know this, so and then, so then you can just mark that this 12x plus 32 is the 13x plus 9, yeah. Because of course the x value is also the same in the crossing point, yes? So here, yeah. And then you can solve the x.
Yeah.
And x was the number of the rows, basically. So here I would have the guests. This was actually the guests, and this was x was the rows. Many times with Jaakko, the x for you would be the time, wouldn't it? Many physics calculations, it's the time, and then with time you have some kind of a variable, like velocity or something else. Okay. I think this was this lesson. Did you learn something? Was it interesting?
Yeah, I think that
Yeah.
for the, like, I remember the equation, I don't remember putting on graphs.
Okay.
Equation. So,
Yeah, and how they look in graphs, but now it's really easy because you don't need any like fancy calculator. You just need the GeoGebra that's free there. You just write it there and then it does for you. But now this one wasn't great. You don't always like get a great result, because then you look like, why this looks so unclear? And well, okay, it was because these lines were pointing quite the same direction. And this y-axis was really like wide. I should have divided maybe the y-axis, put it in a different scale or something. You can do the scaling in GeoGebra as well. You can modify the scaling. Yeah. So if you need to get some kind of a figure quickly, you can just put it there if you know the equation, and you can read it. So you can just copy it and put it into your report or whatever. But for sure, with Jaakko, you use some other kinds of, well, Excel. Yeah. From Excel for sure, but I think even GeoGebra is even like easier maybe. Okay. Thank you. So then next week we continue with the right triangle. Many of you have already done something with it, haven't you?
yeah, that one's, I think that one I'm already in for it, not to it's easy.
Okei,
Yeah.
joo.